A very warm good morning to one and all present over here class. Welcome to the digital platform of APS. Now this is Pavan Kumar. Today I will discuss some concept related to direction cosine. So see, in vector algebra also there is some topics related to direction cosines. Now see, direction cosine. Direction cosines. Now what is direction cosines? See, first of all, let P be any point represent in three-dimensional space such that P coordinate is x, y, z with respect to origin O having coordinates 0, 0, 0. Now you will see so this is 3D space, this is x-axis, z-axis, and this is y positive axis, x positive, z positive. Now see, this is the points P having coordinates x, y, z. Now the direction cosines of point P. How we can represent? Direction cosines of P or position vector. We can consider OP also. So first of all, we have considered P be any point represent in three-dimensional space such that P having coordinates x, y, z with respect to origin. Then join OP. Join OP. Then let the vector OP is making an angle of alpha, beta and gamma with respect to positive direction of x, y and z axis Now the direction cosine suppose this line OP or this is the vector OP making an angle alpha with positive x-axis and this line is making an angle of beta with positive y-axis and this is gamma with positive z axis. Now the direction cosines of point P, or we can write cosines of vector OP is denoted by L, M, N respectively, with respect to x, y and z axis respectively, and defined by L is equal to cos alpha M is equal to cos beta and N is equal to cos gamma. So this is the direction cosines. Now you can see. Now again I am repeating. First of all, you will consider any points P in three-dimensional space and joined with respect to origin O. So this will be the position vector of point P, and this vector R. This vector R means OP. The vector R means OP vector is making an angle of alpha, beta, gamma with positive x, y and z axis respectively. Now the direction cosines of this line OP is denoted by L, M and N. Now L, that will be equal to cos alpha, M that will be equal to cos beta, and N that will be equal to cos gamma. Now this is the point, means what we can write direction cosine dr, that is cos alpha, cos beta and cos gamma. Now I will come to the relation between direction cosines. See, now you will see from figure or relations, we have to write the relations. Now see, relation between direction, cosines, since L is equal to cos alpha and M is equal to cos beta and N is equal to cos gamma. Cos alpha is the ratio of base upon hypotenuse. So hypotenuse is R, we have considered, and this is OP, you know. This is similarly Y by R and this is similarly Z by R. Now where we can write, where length of vector OP, that is, we have considered R, or R is equal to mod of vector OP. Now we have considered this is the length of vector OP. Now you will see, suppose we have considered equation 1, equation 2, equation 3. On squaring this equation and then add, so what you will get the result? This result will be cos square alpha plus cos square beta plus cos square gamma, and cos square alpha result is x square by r square. This result is y square by r square. This result is z square by r square. And you know, this r result is root over x square plus y square plus z square. And now this result we can write x square plus y square plus z square whole upon r square. And you know, x square plus y square plus z square result is r square. So this result will be r square upon r square, result is 1. Now what we can write? We can write its result is 1. So cos square alpha plus cos square beta plus cos square gamma is equal to 1. Now this is the relation. This is the relation. And L square plus M square plus N square is also 1. So see, now we can write there are two relations, that is cos square alpha plus cos square beta plus cos square gamma, result is 1. Now L square plus M square plus N square result is 1. First formula is here. And now second formula, cos square alpha plus cos square beta plus cos square gamma is equal to 1. Now this one is totally completed. Now I will come to the next topic. The next topic is The next topic is, since you know cos square alpha plus cos square beta plus cos square gamma result is 1. You know this formula? Since sin square alpha plus cos square alpha result is 1, this implies 1 minus sin square alpha plus 1 minus cos square beta, sin square beta, this is sin square beta, plus 1 minus sin square gamma, result is 1. Now this result will be, what we can write? Minus time or 3 minus 1 plus 1 plus 1, 3 minus sin square alpha plus sin square beta plus sin square gamma, result is 1. Now what we can write? We can write sin square alpha plus sin square beta plus sin square gamma is equal to 2. This result is 2. So 3 minus 1, this will be 2. Now the formula becomes if cos square alpha plus cos square beta plus cos square gamma is equal to 1, this implies, or then sin square alpha plus sin square beta plus sin square gamma will be equal to 2. Now this is the formula. Now you can see. If any doubts, can clear it. This is the relation between sin alpha sin beta and sin gamma. So cos alpha cos beta cos gamma relation gives 1, and the sin alpha sin beta sin gamma relation gives 2. Now see, if any doubts, can clear it. If any doubts, can clear it. Now I will come to the next topic. The next topic is angle between two vectors, scalar product or dot product. Now see, now scalar or dot product of two vectors. Scalar or dot product of two vectors. Means, to explain this topic, first of all you have to consider two vectors. For any two vectors, vector A suppose and vector B, the scalar or dot product scalar or dot product of two vectors A and B is denoted by A dot B. A dot B. And defined by the formula vector A dot vector B is equal to mod of vector A into mod of vector B into cos theta, where theta is the angle between two vectors. Where theta is the angle between two vectors. Vector A and vector B. So see, let us consider in suppose we have considered this is vector A and this is vector B, and this is the angle between two vectors theta. Now the scalar product that is A dot B, and A dot B you can define A dot B is equal to mod of A mod of B cos theta, where A is the mod of A is the length of vector A and mod of B is the length of vector B. Now scalar product suppose you have to find, so in case you will find the length of the product of their vectors with cos theta, means all term that will be multiplied, and now result you will get A dot B is equal to AB cos theta. Now see, if any doubts can clear it. This is the intersection of axis, this is the origin. Now consider these points, suppose A and B having coordinates, suppose A1, A2, A3, and this coordinate is B1, B2, B3. Now position vector of OA or A, what we can write? Position vector, suppose position vector of vector A we can write A1I vector plus A2j vector plus A3k vector, and B1 B vector B1I